Delivering innovation for over 34 years and backed by employees worldwide, Nordson Asimtek's team of experts are ready to support your next adventure.
Welcome to the AIM booth here at IPC Apex 2018. I'm delighted to be joined by Tim O'Neill, Technical Marketing Manager. Nice to see you again, Tim.
Nice to see you too, Trevor.
Yeah, okay. So, we talked back at Productronica actually about these two alloys, REL 61 and REL 22. I think one of the key things we want to talk about here is that you actually won an award,
Yes.
which is sitting in front of us, the NPI, so congratulations.
Thanks very much. We were really thrilled to get it. It was, I think, an acknowledgement of all of the hard work and research that we put into these materials.
So we'll come back to the REL 22 in a moment, but I want to start with the REL 61, which is, you know, it's like a SAC alloy with a low melting point. Can you tell us a little bit about the features of that?
Sure. So we have the two alloys, REL 22 and REL 61. REL 61 fits a niche in the market for a low-cost alloy that performs similarly to SAC 305 in process. So you get good barrel fill, whereas many of the other low silver alloys, they don't flow as well as a SAC bearing alloy. One of the benefits of adding silver to the alloy is that it dramatically improves wetting. Take the silver out, that attribute goes away. So by manipulating the silver content and adding a little fairy dust, we've been able to mimic the performance of a SAC alloy. We've lowered the melting temperature to some degree, and we've created an alloy that has a luster and shine similar to tin lead, believe it or not, as opposed to the frosty appearance of SAC. Interestingly, now that we've got more field data for rework and wire solder, we've actually got a tremendous amount of positive operator feedback, so it's easy to work with as well. So it's a very good product. We expect that its niche will be to replace other low no silver alloys when customers are having trouble achieving barrel fill on thick boards, and just in general offering the market an alternative to SAC 305 without the compromises of other low and no silver alloys.
So reducing the silver obviously reduces the cost a little bit. You've replaced a little bit of that with some bismuth into the process, but you know, just a small single-digit amount of bismuth, so it's not going to affect the brittleness.
Yeah, well, the fact that the RoHS exemptions expire in July 2019 has opened bismuth back up as an element that can be incorporated into a solder alloy. And when I get the chance to wander around the show, I'll be looking at my competitors' booths because I assume we're all going to be moving in that direction. Bismuth does a lot of good things for electronic solders.
Right, absolutely. So, talking about applications though for this, are you looking more at consumer type products, that type of thing, where they need to have the strength but not the, you know, trying to reduce the cost?
So our market research on the product indicates that, yes, precisely, the EMS market and the consumer electronics market have been the biggest evaluators of the material, both in surface mount and in through-hole technology. So we've seen a fair amount of pot fills for full waves, selective solders, as well as solder paste. I think we have over 135 solder paste samples in the field as of last year for just the REL 61.
Wow. All right, so you're already getting a lot of good data back from that, I'm sure.
Yeah, and one of the things we've also, the data we've collected from the field trials is that we're getting much lower voiding on bottom terminated devices with both of these alloys. And as we mentioned before we went on the interview, metal makes up 90% of solder paste by weight, so everybody would assume that the flux is what is the contributor for voiding or minimizes voiding, but in fact the solder alloy has a pretty significant impact as well. We've consistently seen void reductions, you know, consistently around 10%, but as much as 50% just by a drop-in replacement.
Really?
Yeah.
Because most of the options that are out there for low voiding alloys, it's mostly the flux that seems to be tweaking.
Well, I think that, yes, this was not an intended consequence, but we're happy that it's the case for sure.
Right, okay. So let's move over to the REL 22. This is your high reliability alloy. Tell us a little bit about the components of that and its applications.
So it's a SAC alloy with some bismuth and some other proprietary additives. Our goal was to create a high reliability alloy that did not introduce, it was a drop-in. We didn't want to introduce process changes in order to use the product. We wanted to be able to go to a user and say, if you just drop this into your process, these are the benefits that you realize. So since our conversation at Productronica, we've actually gotten 2 very large studies completed by our customer base. Our market research for this product indicates that the automotive and LED lighting markets are particularly sensitive to the thermal degradation that occurs with SAC 305 at high temperature. So SAC 305, if exposed to temperatures greater than 120 C for any period of time, its mechanical strength can be halved relatively quickly. So if you're in an environment like an LED where you now have a lot of CTE mismatches between the materials, and you've weakened the solder joint, you're going to have a solder joint failure relatively quickly. And in fact, one of the major LED manufacturers did a pretty comprehensive study on this solder fatigue mechanism for SAC 305 alloys. With their cooperation, we submitted REL 22 samples, and I think this is new data since Productronica. They actually were getting 600 cycles from a SAC 305 solder joint before they were getting failures. They exceeded the test criteria of 2,000 cycles with REL 22 and didn't get one failure. So it was a pretty dramatic improvement in thermal fatigue, thermal cycling performance versus SAC.
I mean, that's a huge problem in the LED business. I mean, they say these lamps have a designed life of 25
Well, that's what they're
1,000
selling
hours. That's what they're selling them as. But the solid state electronics behind it typically doesn't last more than 5,000 hours.
Right.
So any benefit you can get to extend that life is significant.
It's big, and particularly, we're not talking the light bulb in your house. We're talking municipal applications, street lights, garages, stadiums, where a light bulb going out is a tremendous expense and burden on the resources to fix them. So if you've made the big investment in LED lighting, you don't want to have to be up there 3 years later fixing and replacing them. So any advantage that we can provide, we recognize the industry is looking for a solution. What we're thrilled with is what REL 22 has been able to accomplish in terms of a competitive market space. So there are several competitors to REL 22. There are other high reliability alloys. And now we have data, customer generated data, so third party independent data, that shows that REL 22 not only outperforms SAC by a wide margin, but it's also outperforming other high reliability alloys as well. Granted, the difference isn't as profound, but we're still number 1. So we're very excited about that. So in fact, one very large European automotive supplier has spec'd out REL 22, and we're in the middle of doing a lot of the process approvals and first articles and things by getting it implemented, and we're hoping for the trickle-down effect where this alloy will become the de facto standard. When people say you need a high reliability alloy, saying are you using REL 22? That's our goal.
Well, it's good to hear of the success of both of these alloys since we spoke at Productronica, and of course that's been validated by your win this week with the NPI award. Tim, thank you for joining us and congratulations.
Thanks very much, Trevor. It's always a pleasure.